Yeah. I don't know. I have interdimensional physics. Is what I'm planning on calling, but editors take it and tweak it. Probably have God in the title. God sells. You know, physics doesn't sell. Yeah.
You talk about protons being the smallest particles. In string theory, though, it gets down to quarks and then eventually vibrating strings of energy. And I think that that's exciting because it bridges this idea of the ether and this unified field. Is there a way to reconcile the two, or do you think that protons are the absolute elementary particles in the universe?
I think that the problem that the string theorists are having with the sort of the base energy product is the need to make it a particle. Particle physics is wrong. If they made a rule for a particle that had to exist more than 10 to the minus 10th seconds, the proton would be the smallest particle. So I think that we need to revisit the concept of particles. And the scientific community got hijacked back in the 60s by the particle physicists. And they now control the consensus. So everything's got to go through them in order to be validated, which is kind of sickening, but that's the politics of the physics world. So I think if you allow an energy source to exist, an extension of physical energy, the whole thing works. You got to relax the conservation of energy law to allow for a universal pool of energy. And I think that's the thing that enabled particle physicists to take off. It's conservation of energy law. Well, it's going somewhere. It's got to go someplace. Well, it's an antiparticle. You know, good God. Yeah.
Can there be a magnetic monopole?
I don't know magnetic monopole.
What they call magnetics, they shoot out both directions.
Then a black hole would be a magnetic monopole.
One direction.
Black hole has two for energy being shot out. I don't know. I'm not a physicist, for God's sake. I don't read this stuff. Yeah.
What are some questions that we should ask tomorrow that you think would be challenging for the speaker to answer?
Oh, the black hole, the dark matter guy?
Yes.
Oh no, for the expanding universe.
I saw that. I saw the dark matter.
Yeah.
I'd say, here's what I'd ask him. What observation was it that led you guys 20 years ago, or whenever it was, to discovering 78% of the matter in the universe? And he's going to say it was a star moving too quickly around the Andromeda galaxy.
Okay, well, you were speaking.
Sorry.
What observation was it that led you to believe that?
They made a huge jump in logic to create dark matter. There was an observation that drove them there. What observation was it that got them there, right? So the observation that got them there was the star moving too quickly. It defied gravity. And the galaxies do the same thing, the spinning of galaxies. They think galaxies are being held together. They're not. They're getting sucked into the black hole. So anyway, that's irrelevant. And the question that I would ask him is, so it's defying gravity. We don't have a good theory for gravity. What causes gravity? What's the force that drives gravity? How does the Earth transmit energy to the moon to pull it toward the moon to create a stable orbit? Their gravitational model sucks, but nobody goes back to ask any questions about it anymore. It's non-existent. They did this, a force status, a strong force, weak force, magnetic force, gravitational force. That's the biggest cop-out in science ever. You make it a force, and you don't need to be logical about it. You don't need any power source or reason. It's open-ended.
So what is the question specifically?
It's why would you invent dark matter rather than going back and revisiting the theory of gravity or the behavior of a galaxy? That seems like a hell of a jump.
Because it's easier?
Yeah. And it doesn't defy gravity. If they came out with something that defied gravity, rejected. If they try to redefine gravity, it can't be done. You can't get a degree in physics unless you can agree with all of the foundational theories.
Should we ask him why the c-squared constant exists?
Yeah. It's a fudge factor. C-squared is a really big number. Yeah. Oh, just this. It was the logical. If you go back historically and look at paradigm shifts for in physics primarily. They happen, there's a consensus community that does not want change. They're very happy with the way it is. The church was very happy with the earth being the center of the universe, you know, in the 1600s. And change becomes very, very difficult because lots of people lose when there's change. And the guys who control the consensus are the guys that are going to lose the most. And so most paradigm changes historically have been bloody. You end up either crucifying people when they're trying to, when Copernicus is saying that the sun is the center of the solar system. And it's going to be the same thing now. But the momentum you get here when a consensus establishes itself is really hard to change. And it's really hard to change from the inside. Einstein was viewed as someone who went to the public. They didn't go through the process, the scientific process of getting the change done. What would never have happened if he'd gone through the process. And there were a lot of people pissed off at Einstein big time back in the 20s because he was shaking things up, and every university had a professor that was going to, his responsibility be diminished if Einstein was right. It's a hell of a hard thing to do. Yeah?
If you sum up your findings in very simple statements, like Draper and the Animal Farm, what would those statements be?
That I believe that the universe is very, very simple. It scales from small to large seamlessly, not linearly, but seamlessly. And that the only missing element in that is the additional power supply that the placeholder ether has held for 2,000 years. Reinserting that back in there, defining it properly, and you can take all of the mind-numbingly bizarre theories that have come out over the last 40 years and discard them. I think it's all simple. And it's not going to be easy to do, and I'm not planning on doing it, but it's doable. And I think as far as energy in the future, there's an unlimited energy supply out there. But you got to identify what it is, let smart people figure out how to harness it. And I think that smart people will figure out how to harness it. We do it today in our generating plants. We spin a conductive material inside of a bunch of magnets. We add an artificial field to copper, and we generate additional energy. We pull it out, we can transport it because the conductive material can line up, you can move it. But you are creating electricity. You're not borrowing electrons from copper atoms. You can run a turbine inside of a power plant for 50 years and come out with exactly the same amount of mass as you started with. You are creating energy, and that's a conversion from a non-physical state to a physical state in an artificially incented environment. We're doing it. It just requires energy to do it, and it's a negative outcome, but we're doing it today.